All right. And so here's part 3. In this part, we're going to be implementing the drive method, which is going to make all of our cars move down the screen. And so I think in the drive method, so I'm going to type def drive and then make a function inside car turtle that takes in self. And then I think most people sort of understand that self.forward will push the car forward. And so I think what a lot of people try is we have this list of cars. If we want to call forward on every car, we can say for car in the list of cars. And now car represents a single car dot forward. Or I'm sorry, not forward, car dot drive, like that, which is going to call the drive method included in every copy of car. So to go forward 10 like that. What I think stumps people a little bit is what happens when we run this. We make the cars, they go to their random positions, and then they move forward once. Also, they moved forward the wrong direction. So there's a couple things we need to fix here. The first thing is that they moved forward the wrong direction. We want them to move forward down, not to the right. The second thing is that they only moved forward once. So I'll start with the first one. When I create each car, a turtle has an intrinsic heading. So if I want it to be headed downwards, I can say self dot set heading and 0, 90, 180, 270. The number of degrees that represents the direction the turtle's going. And now if I run this, they should move down once. Notice how every time I make a change, I run the code to see what the change does. I'm checking my work as I go forward. All right. And I didn't actually see if that went down, so I'll run it one more time. And they did indeed go down now. So that heading controls. What that tells me is I made exactly one change to the code. I changed something in this init. I changed the heading of the car, and that confirms to me that set heading controls the direction that the car is going to move. And now on to our second problem, which is when we call drive, it only goes forward once. So the one way that I've seen people try to address this is they say, well, I'll put this in a loop, right? Because we want it to move forward continually. While true, and now this while true loop, aka forever loop, owns this move forward command. Let's see what happens when we run the code there. So only one car is going to go forward forever. And the reason why that is because when we call car.drive, we have a list of cars. So there's 5 cars in this list after these 3 lines of code run. These 3 lines of code build that list. And so for the first car, we call drive. And when we call drive, we're going to go to that car's copy of this drive method. And it's going to go while true. And then it's going to execute the code. And then it's going to go while true, and it's going to execute the code again and again. So we're going to go forever in this loop. And consequently, because we're forever stuck in this loop, we're never going to call drive on any of the other cars. So the way that we get around this problem is we move this while loop. We want to go forward forever. We want to do a lot of things forever. So it's scoped too low. We want to, anytime we call drive, we want to go forward. But what if we put it out here and make it so that this for loop itself is owned by the forever loop, the while true. What this is saying is forever, go through all the cars in our list and move them forward. And now, let's see what happens. Now notice all the cars go forward forever. And so the placement of that while true loop actually makes a really big difference. We can put it at a different place in our program to capture more things within the scope of our forever loop. And so this is how we would do drive. And this is how we would make sure that all the cars drive. I think what this shows is that if I'll just do a demonstration. I'm going to print out code execute sequentially. So we're going to run line 58. We're going to run this loop, and then we're going to print what is inside the list after this loop is run. And here it is. So the main thing this is showing is that there's this thing called a car object inside the list, another car object, another car object, and another car object. And this is what I mean when I'm saying that calling capital C car here makes a copy of the whole class for the object to use. It really does just make a copy from that template. And so calling car.drive, it only calls drive on a specific car. So we have to do it on every car. And that's why having this while loop out here is helpful. It allows us to call drive on every car rather than putting the while loop inside drive and getting stuck just in one car's drive. So that is how we got the cars moving. In the next part of the tutorial, we're going to do the relocate method. And it'll be similarly fairly straightforward. Well, I don't want to say it's straightforward. I think that these are some pretty big ideas, making the transition from procedural to class-based code. And what I mean by straightforward is it's not that much code to actually write, but it's a very different way of thinking. And getting used to that way of thinking is going to take practice. And I know that y'all are up to the task, so good luck. And make sure to always practice writing this code. Make sure to practice writing the code and understand what's happening when you write it. That's how you're going to get good at programming. Just practice making the keystrokes, pairing them with the thought process. And so, good luck, guys.